Hi, Tom the Professor here. It's time for another problem. Let's get started. How about this time we try the super scary type SAT type question, where we've got two cars leaving a station and getting somewhere at some point. Put the text on the screen if you want to give it a try. This time for the what do we know, I'm going to use a picture in addition to just writing out the information. So we'll start at time t equals 0 hours. We have one car, which I will call car A. It's the red car here, starting 48 kilometers from our 0 point and traveling at a speed of 36 kilometers per hour. At time 0.5 hours, it's 30 minutes later, the red car has continued on its journey at 36 kilometers per hour, so it's no longer 48 kilometers away, but further along the path. But at that time, car B, the blue car, will start from the 0 point and travel at 48 kilometers per hour. What we want to find is at what time will car B pass car A. Now it should make sense that eventually that's going to happen because car A is moving 36 kilometers per hour and car B moving at 48 kilometers per hour. So eventually it's going to catch up. We just want to know at what time that happens. Now of course this sounds like a super scary problem, but hopefully when we get through this you will see that this is really not too bad at all. In fact, we only really need one equation to do this problem. So let's take a look here. The speed for both cars is constant, so what we need to do is relate where the car is with how long it's been traveling. So we're relating the position of the car with the time that's elapsed. The equation that does that is our distance equation, which you've seen me use before in some of these other videos. The distance is the initial speed times time plus half the acceleration times the time squared. Now in order to solve this problem, we just need to modify that equation a little bit because this measures distance and I want to measure position. Okay. In order to do that, we just notice that distance is a difference in position, so we can write it that way. Instead of writing distance, I will write x minus x naught, which is the position the car is at time t, minus the original position where it started. Okay. The rest of the equation on the right hand side looks exactly the same. Now since the cars are, so that's the only real big modification I have to make to this equation in order to use it. The other thing we're going to do though is that since the cars are traveling at a constant speed, their acceleration is 0. So I can get rid of that 1/2 a times t term completely because the a is going to be a 0 there. If we rearrange the equation then so that we're measuring the position at time t, that equation is given by the initial position plus the initial speed times the amount of time that's elapsed, right? Very short equation, and everything we know in this equation except time and where the car is at that particular time. Okay, so let's take a look at what happens to car A. So I'll start with car A. Here's my equation. What I need to do is fill in the initial conditions under which the car is acting. So that's at time t equals 0 hours. We'll pull my picture up here and we'll look. The red car is 48 kilometers away, so we'll put its initial position here at 48 kilometers, and it's traveling at 36 kilometers per hour to fill in that equation there. Right? When we move on to car B then, it's start with the same thing. It's starting at the 0 kilometer mark, so I can put in 0 kilometers into that equation. Is traveling at a speed of 48 kilometers per hour. But with the time here, I need to adjust the time in this equation because the red car has been traveling for half an hour already. So I need to take that into account. The easiest way to do that is to think about what you want to happen. At t equals 0.5 hours, I want the position to be 0 kilometers for car B. Okay, so that means I need to get rid of this 48 somehow, and I do that by making the time term here equal to 0. So t minus 0.5 hours, when we put in the 0.5 hours for t, we get a 0. 0 times 48 is 0. Starting at position 0 my position for car B is 0. You see how that works? That's the toughest, sneakiest part of this entire problem. It's not the equation bit or how we do the rest of the math. It's adjusting that time so that we take into account the half hour that car A has already been traveling. Okay. So all that's left to do then is to figure out what time it is going to take for car B to pass car A. Now, when car B passes car A, what we know is that the position will be the same. The x on the left-hand side of each of these equations will be equal when the cars pass each other. Okay, so that's all I'm going to take now is I'm going to take those two equations and I'm going to set them equal to each other. So from the left-hand equation for car A, we get 48 plus 36t. I've left off the units here just to make it look a little less scary. And from the right-hand car B equation, I'm gonna get rid of that 0 because it's a 0. So we have 48 times t minus 0.5, again getting rid of the units there. And those two have to be equal when the cars are in the same position, when one car is passing the other. Okay, so that gives us this equation. We now just have to distribute on the right-hand side. We gather all the t's together, all the constants to the other side, do a quick division, and we find out that after 6 hours, car B will pass car A. It turns out that that's 264 kilometers away if you wanted to know. It didn't ask us for that, but, you know, just in case you want to know. So it takes 6 hours. 6 hours of driving to catch up and pass the other car. And that is all there is to this particular problem. If you've got any questions about it, make sure you leave a comment. Hit me up on social medias and that sort of thing. Let me know. And then hopefully next time you run into this problem, you'll be prepared. Next time you have to take the SAT, I suppose. Make sure you like and subscribe to the video if you liked it. Make the YouTube happy. Get these pushed out a little further. You can always contact me on my social medias at Tom Teaches Physics. Check out my blog site, tomteachesphysics.com, for everything else I'm working on, including some online courses and other things that you might be interested in, like some fabulous merchandise. Everything that goes along with that blog that's listed there goes to help me do the things I do in order to produce these videos and the content for the blog. So thank you very much for helping. Until next time, I will see you next time.